of this standard electrode reduction potential that is given in your book. As I told you, at the top you have highest value of standard electrode reduction potential, and as you go down it decreases, it becomes 0, and from there it becomes more negative, and the least value is given at the bottom. So these are the standard electrode reduction potential. Now this table, this series is known as what? Electrochemical or electromotive series. Electrochemical series. Okay. So this series, from this series, as I told you just now, so many things, so many properties can be predicted. Application of this series is very important, okay, for this electrochemistry. So definition wise, it's a table in which a table which represents an arrangement of various electrons in the decreasing order of their standard electrode potential is called as electrochemical series. So at the top you have highest value of electrode potential. As you go down, you have the least value of electrode potential. So here you have highest values of E0 at the top, and as you go down it becomes 0, and 0 is for hydrogen, please don't forget. And as you go down it becomes more negative, and at last you have lowest value of electrode potential, standard electrode potential, or E0. In a short way we can write E0. So this series is known as what? Electrochemical series. And one of the applications, as I told you just now, from this series we will be able to tell which electrode will be acting as anode and which electrode will be acting as cathode. There are so many other importance of electrochemical series. So let's discuss them one by one now. So the first one, so this particular series, okay, please refer to this book, and you don't have to remember exact values of electrode potential, standard electrode potential, but you have to remember its relative position in the series. You have to remember its relative position in the electrochemical series. So importance of electrochemical series. Importance of electrochemical series. Number one, predicting the cell potential. So from this standard electrochemical series, we will be able to predict or calculate cell potential. We will be able to calculate cell potential. And to calculate the cell potential, you have to remember this formula, that is E0 cell is always equal to electrode potential of reduction potential of reduction half cell, that is cathode, reduction potential of cathode minus reduction potential of anode. Okay, so E0 of the cell, okay, that is cell potential will be equal to reduction potential of cathode, that is cathode is always placed on the left hand side, or you can write E, this is your right hand side, so E right minus E left. So E0 of the cell will be equal to E right minus E left. So you have to remember this, or you can write E0 cathode or E0 cathode minus E0 anode. So you please remember this one, okay? So don't get confused. Like for zinc and silver. So let's use those values, okay? Let's calculate this for zinc and silver. It's given in the example. So they have given you here. Calculate the EMF of a cell in which the following reaction takes place. So they have given this zinc 2 plus getting 2 electron and converted to zinc, and its standard reduction potential is given as minus 0.76 volt, and the next information that they have given is Az plus 1 electron converted into Az. Value of Az is equal to 0.79 volt. So these two individual reduction potentials are given. So we have to use them here to get what? This cell potential, the total cell potential. So here, how can we do it? Now here you know E naught cathode minus E anode. Now with this information, from this information, how can we know which one is the cathode and which one is anode? So that's your problem. No? So if you have listened to what I told just now, just before a few seconds, you would have easily told it. I have told that if it is more negative, means smaller the value of these potentials, then this, comparing these two values, which one is smaller? Obviously this one, minus 0.76 volt. So they are always willing to give up the electron. They are willing to give up the electron means what? They are oxidized. They are what? Oxidized. And if it is oxidized, where should it be placed? It should be placed at anode. It should be placed at anode because oxidation takes place at anode. Therefore, this will be acting as anode, this will be acting as anode, and this will be acting as cathode. So let's put on the values of this reduction potential. Here, this is cathode. So which one is used as cathode? The higher value of that is 0.79 volt minus this minus 0.76 volt. So if you calculate it, you get a value as 1.55 volt. 1.55 volt. So you got the cell potential by making use of what? Electrochemical series. From the electrochemical series, you got these values, and by looking at these values, you will be able to get the of the cell. And here the most important point. Please remember this. You will be asked this portion that I told, which one will be acting as anode and which one will be acting as cathode. The lower value will always be the lower value of E naught will be always placed as anode. Please remember that. And number 2, predicting anode and cathode. That just now we discussed. From these values, we can say which one will be acting as anode and which one will be cathode. The third importance of electrochemical series is feasibility of a redox reaction, and this is very important. Okay, feasibility of a redox reaction. So let me tell you this one. When feasibility means whether this reaction will take place or not. Okay, so feasibility of a redox reaction can also be predicted from the EMF value of the redox reaction, and this is very important. If EMF for the given reaction comes out to be positive, here it has come out to be what? Positive. EMF value has come out to be positive. Then what happens? The reaction is feasible. The reaction is feasible. That means whenever you place this zinc as anode and this silver as cathode, then you are getting what? You are getting this EMF value as what? 1.55 volt, then this reaction is feasible. That means this reaction takes place. And if the EMF value comes out to be negative, minus sign having minus negative in front of it, then the reaction having EMF value as negative is not feasible. That means that reaction will not take place. Okay, remember this. And from the electrochemical series, you will be able to tell which one is stronger oxidizing agent and which one is weaker reducing agent, oxidizing agent, everything. Okay, so as I told you, from top to bottom, as you go, Anode value keeps on decreasing. It keeps on decreasing, 0, then it becomes more negative, least values at the bottom. So the ones which are present at the bottom are strong oxidizing agents. Not oxidizing agents, they are willing to give up the electron, means they are being oxidized, but they will be acting as strongest reducing agent. The ones which are present at the top are the weakest reducing agent, and the ones which are present at the bottom are the strongest reducing agent. Please remember this. And one more importance of this electrochemical series is it can be used to correlate with equilibrium constant. So another of the importance of this electrochemical series is determining equilibrium constant. Determining equilibrium constant for a reaction. Equilibrium constant for a reaction. So here, you know, delta Z gives free energy is equal to minus RT ln K minus RT ln K, where K is equilibrium constant, and you also know delta Z naught equals to minus NFE. This small e has to be replaced with what? Capital E, that is EMF of the cell, E naught. So minus RT ln K and minus NFE naught cell. And this K is the equilibrium constant. So this gives free energy. This also gives free energy. These two equations. Now if you combine these two equations, then you get what? You can get the value for equilibrium constant. That is, if you compare these two, then it can be written as minus NFE naught cell is equal to minus RT ln K. Now E naught, this minus minus we cancel out. So E naught of the cell will be equal to RT by NF E naught cell. This one, by knowing the value of this E naught cell as we did for the previous sum, we can get not this E naught cell. It has to be ln K. Here ln K. Now knowing the value of E naught of the cell, knowing the value of E naught of the cell, okay, we can calculate. These are constants, all constants. These are all constants, and this n is the number of electrons that is being transferred in this reaction, redox reaction. F is the Faraday, and since these are all constant values, R, T, N, and F. R, T, F are constant values, and depends upon the number of electrons that is being transferred in redox reaction. That means all these four quantities are known. After knowing the E naught of the cell, if you know E naught of the cell, then we can calculate it from its standard reduction potential values given from that electrochemical series. What is unknown? The only unknown is this K. that is equilibrium constant. So this can also be calculated by using this electrochemical series. Now you have to remember the importance of this electrochemical series is very vast, and from here you will be asked numerical. It could be from here, or you might be asked to calculate the EMF of the cell that can be calculated by knowing the standard electrode potential for each hassle that we have done for this. Just now we did for silver, and we have discussed for silver and I think zinc. So this is the importance of electrochemical series. Please practice them properly. Whatever I have told you, whatever I have told you, if you remember it, you will be able to do it. You will find this electrochemistry very simple. Please follow whatever I have told you. So keep practicing. There are certain numericals in your book, certain problems are there. Practice them properly, and with this knowledge, in the next video we will be discussing about Nernst equation. Thank you.